to determine the monthly billing if the pump is running 30 days at 20 hours per day. So, paano yung magiging approach natin dito? Since ang hinihingi sa atin is yung motor power, given yung motor efficiency, then let's try to use the efficiency or the motor efficiency formula, which is the brake power divided by the motor power. Um, Motor efficiency is given at 85%. Motor power yung hinahanap. Then brake power, kailangan natin ma-determine. Unfortunately, hindi siya binigay sa problem. So, two unknowns, one equations, hindi natin makukuha to. We need to determine the brake power. We can get the brake power by using the equation of the pump efficiency. But 39.36. So let's just substitute this the fluid power, or sorry, the total dynamic head in this equation to get the fluid power. So the given fluid here is water. So we know that the density or specific weight ng water is 9.81 kilonewton per cubic meter. 9.81. Volume flow rate, however, hindi binigay si volume flow rate, pero binigay naman si velocity together with the diameter ng ating discharge flange or discharge. So we need to convert it into volume flow rate by using this equation. Q is equivalent to area multiplied by the velocity. So first, let's determine the area by using the equation ng ating circle, which is pi d squared over 4. If clear sana yung feedback niyo sa akin, papakompute ko sana to sa inyo kasi since hindi ko nga kayo naririnig ng ayos din, then sige lang, ituloy ko na lang muna din to. So as you can see in the given, yung velocity natin dito will be in feet per second. Yung diameter natin is in inches. So gawin na natin siya standard. Gawin natin siya both in feet. So 2 divided by 12. To make it in feet, 2 inches divided by 12. Then let's get the area. So the area will be 0.01218 meters squared multiply. This is feet squared. The velocity of 5 feet per second. So we'll have the value of 0.10908 cubic feet per second. Pero kung titignan natin dito sa pagkuha ng ating fluid power, ang ating total dynamic head is naka-meters. Ang ating specific weight is in cubic meter. So yung cubic feet per second, convert muna natin siya into cubic meter per second. So this is equivalent to 0.003089 cubic meter per second. Para makakancel natin yung mga unit mamaya. So let's substitute it in this equation. Volume flow rate is equivalent to 0.003089 cubic meter per second. Multiply by the total head, which is 39.36 meter. So let's cancel this unit, cubic meter, leaving us with kilonewton meter second, which is equivalent to fluid power of 1.1927 kilonewton meter per second is equivalent to kilojoules per second, which is equivalent to kilowatts. So the fluid power is 1.1926 kilowatts. Pero hindi pa tayo tapos kasi hinahanap sa problem is the motor power in HP or the horsepower required by the motor. So let's just remove this unnecessary. We can substitute the value of the fluid power into this equation. Since given naman si pump efficiency, then we can find already the value of the brake power. So brake power is equivalent to fluid power, which is 1.1926 divided by the efficiency ng pump, which is equivalent to 0.7 or 70%. That will give us the value of brake power 1.704 kilowatts. Now we have the value of brake power. We have the value of the motor efficiency. Now we can get the value of motor power. So motor power is equivalent to brake power 1.704 kilowatts divided by the efficiency ng motor, which is equivalent to 0.85% or 0.85 or 85%. That will give us 2.0045 kilowatts. However, we need to convert it into HP. So 2.0045 kilowatts for every 0.745 kilowatts, there is 1 HP. So final value natin ng motor in HP, motor power in HP would be 2.68 HP. So in the market, wala namang exact na 2.68 HP. So kung tayo papipiliin ng motor, we need to select a higher one. Kung merong value na 3 HP, then kukuha tayo ng 3 HP motor. Pero for the sake of this calculation or problem solving, we will still use the value of 2.68 HP. So we satisfy already the first question. Motor power in HP is equivalent to 2.68. The next question is the monthly billing if pump is running 30 days at 20 hours per day. So the formula for the monthly billing is equivalent to the motor power in kilowatt multiplied by how many hours the motor is running per day, which is 20, multiplied by how many days bago tayo mag-billing. Usually naman is 30 days or 1 month. So yung multiply lang natin yan times the cost of the electricity in peso per kilowatt hour. So we have the value of the motor power in kilowatts. That is 2.0045. So multiply natin sila sa 20 hours per day times 30 days kada billing. to cancel out. Kilowatt hours divided by kilowatt hours. That will give us a unit of peso only. So the answer will be, the monthly billing will be 3,127.02 pesos. So that's for our first problem. Kapag may clarification kayo, just message me kasi hindi ko nga maintindihan yung feedback. Nagkakaroon ng feedback pa nagsasalita kayo eh. If wala, we can move on to the next problem naman. Pero I hope it's clear. Balikan lang natin yung analysis. Since binigay sa problem yung ating mga efficiency ng pump, efficiency ng motor, nahanap naman dito yung motor power, ginamit natin yung formula for pump analysis. We use the formula such as the fluid power, pump efficiency, and the motor efficiency to determine the motor power. So we use the pump analysis here na discuss natin kanina. So for next problem naman, let me read it again. A certain, this is 1.5. Certain 1.5 kilowatt pump running at 1,600 RPM has an inlet diameter of 20 centimeter and the discharge line is 12 centimeter in diameter. The output from the pump is 2,800 liters per minute of water. And the center line of the pump discharge is 1.5 meters above the center line of the intake pipe. Determine the efficiency ng ating pump. So, let us list first kung ano yung mga given. So, binigay rating ng ating pump which is 1.5 kilowatts. Isama lang natin dito. Based dito sa ating pump analysis. Pag sinabing certain 1.5 kilowatt pump running at 1,600 RPM, ano sa mga ito yung gagamitin natin or ano yung dinidiscuss dito na power? So, hindi siya yung fluid power kasi ito yung rating ng pump natin. So, most likely, siya yung ating tinatawag na brake power kasi siya yung input sa pump o siya yung magiging pump rating. So, yung 1.5 kilowatt na yun, that will be the brake power. Yung nangahanapin natin, mamaya will be the fluid power. Kasi kailangan natin ma-determine yung kailangan natin ma-determine si pump efficiency. So remember guys, kapag nagbigay ng rating, which is 1.5 kilowatt, most likely that will be the brake power. So ano yung hinahanap sa problem? Pump efficiency. So binigay din ang volumetric flow rate, which is 2,800 liters per minute. Binigay din ang diameter, outlet diameter or discharge diameter, which is in 12 centimeter, even the inlet diameter or suction diameter, which is 20 centimeter. So let's draw first the schematic nito kasi may binigay tayo or may binigay siyang elevation which is 1.5 meters. Sinabi dito na the center line of the pump discharge is 1.5 meters above the center line ng intake discharge. So we can assume or we can write it in this way. Kung ito yung suction line natin, ito yung discharge line natin, and the difference between those two is 1.5 meters. Since sinasabi dito sa problem na the center line of the pump discharge is 1.5 meters above the center line ng intake discharge. Or pwede din naman they are on the same elevation. So this is 1.5 meters. Kasi ang mahalaga is 1.5 meters is above the center line ng intake discharge kung nasan yung ating discharge. So it will be represented by C sub D, or we can say represented by ZS minus C sub D. Maalin doon is tama naman. Pares na sila magiging value. Sorry, C sub D minus C sub S. Since ang hinahanap is pump efficiency, let's go back. So kung paano ba natin kukuha si pump efficiency? We can get the value for pump efficiency by dividing the fluid power into the brake power. Ito yung hinahanap natin, pump efficiency. We have the brake power. So, however, wala tayong fluid power. To unknown, one equation, so we cannot solve the problem. Then we need to find the value for the fluid power. Fluid power is equivalent to specific weight ng water, given is water again, so that will be 9.81 kilonewton per cubic meter, multiplied by the volume flow rate. Volume flow rate is given at 2,800 liters per minute and multiplied by the total dynamic head. To get the volume flow rate, since naka-liters per minute siya, convert muna natin siya into cubic meter per second. So 2,800 divided by 1,000 liters per 1 cubic meter. And 1 minute divided by 60 seconds. Then we can have the value of volume flow rate as 0.04667 cubic meter per second. For total dynamic head, since hindi binigay si total dynamic head sa problem, pero binigay naman yung ibang parameters such as elevation head, difference in elevation head, which is 1.5 meters, diameter ng suction, diameter ng discharge. So there will given naman si volume flow rate. So makukuha natin ang difference in velocity head ng suction discharge. Hindi binigay si friction losses, so let's make it 0. Hindi rin binigay yung pressure gauge na na-register before the suction and before the discharge, so let's just make it 0. So to compute for the total dynamic head, so we just need to sum both the difference of the elevation head and the velocity head. But before that, let's get the value first of the velocity. So using our value for the volumetric flow rate, we can get the velocity at suction side by dividing it into the area ng suction, which is pi diameter, which is 0.2 meter squared divided by 4. And ang magiging value niya is 4.126 meter per second. Same din sa ating velocity sa discharge. Let's divide the volumetric flow rate, which is 0.0467 cubic meter per second, to the area ng ating discharge lunge, which is pi d squared over 4. Yung ating diameter will be 0.12 squared. Then makukuha natin velocity here will be 1.48 meter per second. Then let's just substitute the values and calculate for the total dynamic head. Don't forget to include the 1.5 meters in the difference sa ating elevation head. So our total dynamic head will be in meters and the value is 2.256 meters. However, hindi pa yun ang tinatanong. Ang hinahanap sa problem is the pump efficiency. But before that, let's just substitute all the values to get the fluid power. So total dynamic head is 2.256 meters. Our volumetric flow rate is 0.0467 cubic meter per second. So we can cancel this unit, cubic meter, giving us 1.0328 kilowatts. So ito yung ating fluid power. To determine the value for the pump efficiency, so we just need to divide the fluid power to the brake power, which is 1.5 kilowatts, and multiply it by 100. So 1.0328 kilowatts divided by 1.5 kilowatts will be 68.8%. So for this problem, gumamit din tayo ng equation or ng pump analysis such as the pump efficiency, the calculation for the fluid power using the total dynamic head, and the energy balance in the pump using the difference in elevation head, pressure head, and velocity head. So I hope it's clear kung paano natin nakuha ang pump efficiency. Okay, last problem to discuss. Okay, hindi ko pa rin naman ito na-solve, so let's try to solve it together. So a pump discharges 8,000 liters per minute of a certain brine solution having a specific gravity of 1.2 to an evaporating pond. The intake line is 25 centimeter in diameter and is at the same level as the pump discharge line, which is 15 centimeter in diameter. The pressure at the inlet of the pump is negative 170 millimeter of mercury. So nagbigay dito ng ibang unit of pressure, which is in height of mercury, or 170 millimeter of mercury. That is negative, means this is vacuum. The pressure gauge connected to the pipe discharges and reads 150 kPa. And its center is 2 meters above the center of the discharge flange. If the pump efficiency is 80%, how much power is required? Okay, so let's write or let's list down what are the givens in the problem. So binigyan tayo ng ating volumetric flow rate, which is equivalent to 8,000 liters per minute. Later, we'll convert that into cubic meter per second again. Specific gravity ng fluid or ng brine solution is 1.2. Diameter ng inlet or ng intake is 25 centimeter. Diameter ng outlet or ng discharge line is 15 centimeter. Let's just make it all so the pressure at the suction of the pump is negative 170 millimeter of Hg or mercury. Then pressure sa discharge, the register sa gauge natin is 150 kPa. Efficiency ng ating pump is equivalent to 80%. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . let's let's draw a schematic first of the problem to determine kung saan natin ilalagay si 2.0 meters. So the problem states that the intake line is 25 centimeter in diameter and is at the same level as the pump discharge line, which is 15 centimeter in diameter. So the intake line is 25 centimeter in diameter and at the same level as the pump discharge line. So same level lang siya dito. So C sub S is equivalent to 0 kasi same elevation lang ng ating center line. While our discharge line is 2 meter above so we can say that C sub 2 equivalent to 2 meters. Next, let's try to solve the problem analysis. Since ang hinahanap dito is, or let's find, dikit mo na kung ano yung hinahanap sa problem, power required. How much, if the pump efficiency is 80%, how much power is required? So again, ang hinahanap dito will be the brake power. Or yung rating ng ating pump, which is the input ng ating pump na brake power naman. So analysis, we can get the brake power by using this equation. Brake power is equivalent to fluid power divided by pump efficiency. So we have the value for pump efficiency at 80%. We are looking for brake power. However, wala tayong value ni fluid power. So before that, kailangan mo natin makuha si fluid power. Fluid power is associated with total dynamic head. So to use that, we'll use this, to find that value, we need to use this equation. So fluid power, substitute natin siya dito pag nakuha natin. So given ba si specific weight? Yes. Given naman si specific gravity, so makukuha natin yung density ng brine solution, then saka natin siya i-convert para makuha natin yung specific weight ng solution. Given si volumetric flow rate, yes, 8,000 liters per minute. However, i-convert na natin siya into cubic meter per second. Total dynamic head, hindi pa given. We need to calculate that using the energy balance equation. So first, let's compute what is the equivalent of 8,000 liters per minute into cubic meter per second. So 8,000 liters divided by, for every 1,000 liter, 1 cubic meter. For every 1 meter, may 60 seconds. it will be 0.133 cubic meter per second. Then for the density of the brine solution, we can use this equation. Specific gravity is equivalent to the density ng ating solution divided by the reference density. Please remember this equation kasi hindi natin basta lang gagamitin si specific gravity or usually lang gagamitin si 9.81 kN per cubic meter kapag binigay si specific gravity. So, since fluid ang ating excuse, ang ating reference material dito, we will use the reference density of the water which is 1,000 kg per cubic meter. So, 1,000 kg per cubic meter times 1.2 para makuha ang density ng ating fluid or ng brine solution which is 1,200 kg per cubic meter. So, density ng ating brine solution is equivalent to 1,200 kilogram per cubic meter. Then para makuha ang ating specific weight ng brine solution, we need to multiply it by the acceleration due to gravity which is 9.81 meter per second. Then ang magiging value niya is 1,200 times 9.81. Let's divide it into 1,000 para maging kilonewton. So 11.772 kilonewton per cubic meter. So we have the value already for the volumetric flow rate which is 0.133 cubic meter per second. We have the value for the specific weight ng brine solution. Let's just find the value for the total dynamic head. We'll use this equation to calculate the total dynamic head. Total dynamic head is equivalent to the difference ng elevation sa discharge and suction, difference ng pressure at both discharge and suction, difference in velocity, and the head losses. Hindi binigay sa problem si head losses, so let's make it 0. We have the difference in discharge and suction elevation. Equivalent siya kay 2 meters. Difference in pressure, kailangan din siya makompute. However, binigay sa problem in suction will be negative 170 millimeter of Hg. So let's compute it first or convert it into kPa. So for every 7.5 millimeter of Hg, there will be 1 kPa. So divide na natin si 170 to 7.5 and we'll negative 22.66 kPa. And then let's find the velocity at the discharge and suction port. Since we have already the volumetric flow rate of 0.133 cubic meter per second, calculate natin yung velocity. Diameter sa suction is 25 divided by 100, which is 0.25. Diameter ng discharge is 15, which is 0.15. So to get the value, let's just solve this equation. 4 times 0.1333 divided by 5 divided by 0.25 squared. So it will give us 2.716 meter per second. Then for the discharge, it will be divided by pi divided by 0.15 squared. Give us 7.5432 meters per second. So let's get the value of the total dynamic head. We have already all of the variables here. So let's substitute 2 meters. Pressure at discharge will be 150. Pressure at suction will be negative 22.66 divided by the specific gravity of fluid. It's equivalent to 11.772 kilonewton per cubic meter plus velocity and discharge is 7.5432. Velocity ng suction is 2.7167, 9.81. So that will give us the value for total dynamic head of 19.335 meters. Please let me know if nagkakamali ako ng calculation. Maganda if masasabayan niyo ako sa pagko-compute. Then let's substitute that to this equation para makuha natin yung efficiency, brake power, since brake power yung hinahanap sa problem. So brake power is equivalent to, let's convert it pa pala sa fluid power. The efficiency ng ating pump. Before that, let's calculate the fluid power using this equation. So fluid power is equivalent to 11.772 multiplied by 0.1333 cubic meter per second times total dynamic head of 19.335 meters. It will give us 30.34 kilowatts. And let's substitute the value here in the fluid power and the pump efficiency of 0.8 to get the value of the brake power. So fluid power is 30.34 divided by efficiency ng pump, which is 0.8. Then brake power is equivalent to 37.926 kilowatts. Let me check if tama yung ating mga solution. So for fluid power, 11.772 kilonewton per cubic meter. Then 0.133 cubic meter per second. Tama naman. Then this will be in meter. Cancel, kilonewton meter per second will be in kilowatts. So tama naman to. Then total dynamic head will be in meter. This is kilonewton per meter squared. This is kilonewton per cubic meter. Cancel meter squared, giving us 1 unit of meter in the numerator. Then for velocity, it will be meter squared per second squared divided by meter per second squared. So tama naman siya. Cancel second squared, cancel 1 unit of meter, giving us 1 unit of meter here. So that's it. The final answer will be 37.926 kilowatts. So I hope clear naman sa inyo to. Then for now, three example muna yung di-discuss natin. Then next week, we'll continue the discussion. Pag may clarification kayo, please message me kasi hindi ko masyadong naririnig yung sinasabi nyo. Mayroong feedback eh.
Okay po, sir.
Kapag may, sino ba yun? Si Jeff? Kapag meron kang question, Jeff, please message na lang. Talagang hindi ko siya naririnig ng ayos eh. Pero for information, we still have 2 weeks before our midterm. So kapag sabi ko nga, pag may na-miss out akong topic this week, then i-discuss ko na lang ulit by next week. Pero ang plan ko by next week is to have sample computation again para ma-familiarize tayo on the equations involving pump analysis, specific speed, net positive suction head, and affinity loss. By next week din siguro makakagawa tayo or makakagawa ako ng midterm natin. So I'll let you know kung ano yung magiging scope and kung ilang items. So thank you very much. Pag may question kayo, please message me. Kung may clarification dun sa ating problem solving kanina. So thank you. Pag wala na naman, we can have an early dismissal. Thank you, class.
Thank you po, sir.
Thank you. Thank you all.
Thank you po, sir.